Welcome to all. See, today we will start analysis of statically determinate pin-jointed plane frames. Already I told you there are two methods, namely method of joints and method of sections. We will come to it. Now, first substatement. Those who want complete control on method of joints, what all I tell today, everything you are right. Remember, some of the principles I will continue in the next class. Continue means what? See, procedure or step-by-step procedure I will give you in the next class. Then somebody will ask, then why this class? This is somewhat a demo class, but very, very powerful. I will guarantee this class you thoroughly understand, you will have no difficulty in future for method of joints, either for this subject or later in structural analysis for solving indeterminate frames or for finding deflection of truss joint or frame joint, and also when you design steel structures. There you require same principle once again. Now, first of all, make a note. Note, analysis means, what is analysis? You should make first note. This all next time I will give it. In case of pin-jointed plane frames, when you consider the members, there will be no bending moment, no shear force, and no twisting. There will be only axial force. See? Axial force can be either compression or tension. So, analysis means we have to find axial force in members. Now, axial force in a member can be either tensile or compressive. See, this all I will explain once again little later in some other way. Okay, start. Now consider member in tension. See, suppose you take a member here. See correctly. This all I told earlier during friction chapter in one class I told. Till once again, see. You take a member, externally you apply outward force. See here, pulling force. This way and this way, both going outwards. This member is in tension. And or, see, class, what all I dictate you tell. See, this line we are writing external effect right here. External effect, or how axial force is developed in a member by considering external action. See, here, take the member, apply force like this, press it both way, put this way. See, member will be in compression. Now, see here, if you consider here, this force will pull it like this. So, therefore, for equilibrium, internally, a resisting force will come this way. See, you can make out here, see, you see correctly here. You see this level, see, or one more minute, see, if you project here, see here what happens. This force comes this way, this force is this way. Or if I project here, see both you see together, that force is acting like this. This force is acting like this. Or here, see, if you apply compression here, this will press here. So resisting force will come this way, here this way. Or if I project here, this joint and this joint, see, a force externally like this, internal resistance like this here, externally like this, internal resistance. So this is external effect. This is internal force developed. Internal force developed, you can write here, for resisting the external axial force. People who tell axial force, shear force, bending moment or twisting moment are internal, I will tell again and again, they are not correct. It is a wrong concept. I will prove it by uploading a class later. Okay. Now, or class. Consider external, internal both together. See here. You write here class. This is only external action. This is internal resistance. This is a small sketch here combining them. Now put a final sketch here. Class. Right here. Considering both external and internal. See. P this way, P this way. Here. P this way and P this way. Now this axial force in this member, whether you see this one or you see this one or you see this one, whichever right here, whichever you see, either the first sketch or the second sketch or the third sketch, whatever you see, it is P tensile. Or I told you something, whether it is external or internal, see, external or internal, force going away from the joint or away from a point or joint is tension. See here, whether you take external or internal, see here, force acting towards the joint is compression. See, whether irrespective of whether you consider external effect or internal resistance. So therefore, make a note, last make a note. If you take any point here, see, don't see these things. If any point you see here, see, one, if this way you get, see, if you consider this point, if you get this way, that is, which is internal, which is external, don't bother. Internal member is that side, this side does not matter. This is tension. Whereas, see here, if the force is acting inwards to the point, this is compression. This already I told earlier, I will explain once again later. So this is regarding analysis, means finding axial force. Now, something in the class I will tell now, then we will go further. Now we will start analysis. There are two methods. That is a basic method. Namely, one, method of joints, other is method of sections. Right now I am starting method of joints. You make a note here. Method of sections later. Right now I won't explain, because once you get perfection in method of joint, I will start method of section. I can tell now, but no use. Now, class, very, very important. What I tell you should write. See, I will dictate something now. People, if you are serious, write. Next class, I am going to give you complete procedure, step by step, do's and do nots, and then regarding support reactions, you can make a note here. Sometimes support reactions need not be calculated. Sometimes support reactions should be calculated, or we have got perfect frames. Sometimes a frame will look like imperfect, but actually it is perfect. Reason is there. That all I'll give you extra note for you. What to do if the question is like this. Very systematically, next class will be fully procedure, maybe more than 1.5 hours. But today what I am doing is, see, when I give procedure, everything is new to you. People won't understand. What all I tell, they will understand it after solving some questions. So best option I decided is today's class. See, today's class I am going to solve a master question. Master question, or a question where if you understand everything if you understand, you will be master or perfect in method of joints. Not only for this subject, later for structural analysis also. See, Later, when I go for structural analysis, when you require member forces by method of joints, what I will do at that time is, I will put the frame here, enter the answer. I will tell, go back to engineering mechanics, study and come back. I will tell that way. I will tell the class number. Now, somebody will ask, sir, how you will enter? I will show it to you. And today's class, I will show you something else. If you master the subject, if you understand thoroughly, then you can do miracles. See, I am going to write a question here. I will use only pen and calculator. I will not write anything. I will fill up the answer here. And then I will not look at the answer. Before starting only, I will write the answer here, somewhere here. Then I will go this side. I will never, maybe don't tell, suppose when I turn here, he is seeing there. Why should I see there? Sometime offline class, what I will do is, I will cover it by something. Cover by a newspaper, something like that. Today I won't do it. Or maybe, who knows, I may cover today. I may put some paper there and cover it. Okay. And the purpose is not to show you my capacity. Purpose is to inspire you or motivate you to learn. Remember, I don't have to get anything by showing my capacity. People who know me, they know my capacity. Okay. Now, what I will do today is procedure. I will keep on dictating briefly. You don't write. If you want, write, but no need of writing everything. You go through the class. See, go through this class repeatedly till you master. Then there is no need of writing procedure because you have already mastered it. Still, next class I will give procedure. Then I will tell you, now go back to previous class and go through once again. So, some statement I will write here. Okay, now, first method of joints. See, some statement I wrote to save the time. Where is that eraser? Here. Okay. First come to method of joints. This is going to be a very long class, remember. This all you write. First consider method of joints. See, black only I will write. Method of joint. See, 1 minute. Method of joints. Method of joints. I already told there are two basic methods, method of joints and method of section. There is one more method, some advanced method called tension coefficient method. That nowhere in the syllabus it is there. It is not required. But anyway, later, someone will, in the comment they may write, sir, please solve a question for tension coefficient method. I may solve later, right? That's somewhat some odd method, but good method. So right now, basic methods are method of joints and method of sections. See, no, method of joints. I will write the first. Remember, as I told just now, today I am solving master question. Procedure I am giving simultaneously, but not writing on the board, dictating. People already told, if you want you can write, but anyway, nothing not required. Next class, from here to there, full procedure with all important concept I will write. Actually, in case you have any difficulty for today's class, there will be no difficulty. You follow seriously. After going through the procedure, once again come back. I will tell you why. Because once I solve the master question, when I give procedure for you, it becomes crystal clear. You will tell, yes, this is the way you have to see. When I tell something, you will tell, yes, this is what he has done it last class. Okay, now, see. In method of, briefly, in method of joints, we consider equilibrium of a joint. of a joint. Actually make, not one joint, all the joints, see, all the joints, but one after other, not at a single time. We consider equilibrium of any joint. You can write equilibrium of selected joint. Okay, selected joint. Equilibrium of selected joint. And remember, we are considering joint equilibrium. Joint equilibrium. Therefore, we are going to get a concurrent force system. Concurrent force system. See, like this. Like this, where all the forces are meeting at a point. Now right here, when you consider equilibrium of a concurrent force system, there are only, see, right here, when you consider equilibrium of a concurrent force system, among the three basic conditions of static equilibrium, namely sigma h0, sigma v0, and sigma m0 is not applicable because why? All are passing through one point. Therefore, only two equilibrium conditions. Two equilibrium conditions. That is sigma h equal to 0 and sigma v equal to 0. Algebraic sum of the components of all the forces in horizontal direction equal to 0 and in vertical direction equal to 0. Next, therefore, joint selected. See, there are only two equations. You can tell two conditions means two. Mathematically you can tell two equations. When there are two equations, only two unknowns possible. See, therefore, only two unknowns can be solved. Therefore, joint selected should not contain more than two unknown forces. Now, in method of joint, unknown force means member force. Or you can tell the joint selected should not contain more than two unknown member forces. Make a note. Any number of members will do. Maybe suppose there are only two members, forces in which are unknown. Yes, you can solve. Suppose there are three members meeting at that joint. Then, if all three are unknowns, you cannot solve it. By chance, among the three, if one force is already known, how I will tell you? Suppose already one is known, then remaining two you can find. Why? Already known means it is not unknown. Suppose member has suppose the joint selected has 4 member forces. If 4 member forces are there, if all are unknown, not possible. If one of them is known, still not possible because 3 more unknowns. But among the 4, if 2 are known, already known, how I will tell? Remain other 2 you can find. That way, if 5 members are meeting, you can solve that joint if among the 5 member forces, 3 member forces should be already known to you. Some will ask, sir, how it is known? Wait for some time. So number of unknowns should not be more than 2, or simple language, joint selected should not contain more than 2 two unknown member forces. See, joint selected should not contain more than two unknown member forces. Unknown member forces. Okay. Now, okay, done. Now, next. When we consider the joint, when we consider equilibrium, this is a very, 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 very important. Next time steps I am giving. When we consider equilibrium of in a joint, that is selected joint, then we have to consider we have to consider what all you have to consider is here. See, three parts are there. One, external support reactions acting on that joint. I will tell in the next class. That is, if that joint is attached or connected to a support. Okay. If that all next class I will tell you, see, don't worry. If that joint selected is connected or attached to a support, then support reactions acting on that joint. Second one, external forces acting on that joint. Any external forces or load, see, here we tell forces. In structural analysis, we tell loads, okay, acting on that joint. And three, forces acting on that joint, very important, from the members connected to that joint. Which are all the members are connected to that joint? What is the force acting on that joint? Force acting on that joint from that connected members. All from okay, joint from all the members, see, connected to that joint. Sufficient now. Later, when I give procedure, see, tomorrow's class procedure will be more than 1.5 hours. Why? Today I am seeing that when I give procedure, everything is clear for you. That is the purpose. Okay, this much is sufficient. Now, one important concept. This is my usual. This is external. This is external. I will ask the people, what is this one? 99.9999% people will tell this is internal. No, it is not internal. If somebody is listening who is having good knowledge, maybe usually very good knowledge means they should be teaching, good reputed teachers. He may be laughing at me now. This person does not know anything. See, he is telling member forces are external. I will tell it is external. It is not internal. Someone will first tell, you don't know anything. You don't know that one. It is internal. I will tell, come and argue with me. When you when you go up the argument, you will go like this. Yes, he is correct. He is correct. Oh, we thought so far. Everywhere I told in the class, everywhere, internal. Suddenly, he opened my eyes. From today, I am a reformed person. I will tell correct thing. It is also external. For this separate YouTube class I am uploading, because so many people may not see this one. But if I upload a separate class, like I told, sometime it's called blunder or some concept which is not correctly told, mistakes, I am highlighting that one. Then they will see it. They will think, let me see what is that mistake he is telling. They will laugh at that time. Internal, he is calling external. I will tell them. I will explain everything. Then I will ask, now tell me, internal. Internal. No, sir, external. Yes, okay. Time being, leave it. I cannot resist telling because 99.99% people are telling this is internal. It is, see, you cannot club external with internal. When you consider equilibrium, only external you are considering. Internal you are not considering. Okay, leave it. I will give a fitting reply for all those who tell it is internal. Now leave it now. I will clean the board and start my master question today. Okay, now master question for method of joints. Thoroughly go through entire class without missing anything. You will get complete knowledge. You will become expert in method of joint, my guarantee. And as I told just now, procedure, reasoning, or some concepts, etc., regarding some reactions, and then so many things are there. Some rules are there. And about support reactions, when required, when not required, step-by-step procedure will come tomorrow. But that procedure, when I give tomorrow, next class, this question will help you now. Because why? You will be knowing, oh yes, we have done that type. Okay. Question is, that is the master question is, find axial forces. So many people, they tell, find forces in member. Okay. Actually, in this chapter, I will tell later. This I will tell tomorrow. Okay, next class. Even though we tell forces, it is actually not force. It is axial force. Okay. Axial forces in all members of given, see, question, don't see there. For the given pin-jointed plane frame by method of joint. Question is here. See, you put the sketch. Neatly put the sketch. See, now one thing you can observe here. 30, 24, multiple of 3. These are multiple of 3. These combined together, it is multiple of 9. Combined together, it is multiple of 3. Combined together, it is multiple of 9. This also multiple of 9. This I set so that decimals will not come. Otherwise, see, you get 17.8489. No, I do not want this class. I want, how somebody will ask, sir, how you know it? I got that control. I know how to set a question so that not all the question possible. Here it is possible. This, I can control the decimal. Okay, this is the question. Now, see correctly, procedure, those who are writing, first find support reactions if required. Answer for this question. That I am dictating tomorrow. Yes, it is required. Why it is required? See, why it is required, you will be knowing tomorrow, next class. See, why it is required, you will be knowing in the next class. Today, it is required. Okay, start. First step, solution. I will start here. Solution. Okay, 1 minute. Okay, I will do one thing now. I will write the reactions so that to save the time. Time also counts. One more thing, it started raining also slightly. So, I will. Okay, we will start. It is raining slightly, but sound is not disturbing because important portion I will wait. First step is, I told, procedure I will tell tomorrow. Calculate support reactions if required. Yes, here required. Why? Next class. See, now, support A. See here. This all already told for you. See, I should not waste time explaining support reaction now. A is a hinge, you write here. A is a hinged support, which will have 2 reactions, vertical and horizontal. So, let we, see, in today's class, something I am dictating, you should write. Let VA and HA be vertical and horizontal reaction at hinged support at A, and B is roller support. RB be the reaction normal to plane of roller at B. See, roller is like this, RB, but here Since the roller is horizontal, note your RB equal to VB. Okay. I remember in case the by chance, see, okay, now all next time I will tell. Okay, now draw a knee, see, this is a given question. Do not write anything in the question. Do not write anything. This should be there, so for reference. Now come here. Now draw one more sketch. See, enter the values. 30, 45, 50, 24, 15, 40, okay. 36, 4 meter, 3, 3, 3, 3, VA, HA, VB. You can do one thing. We will assume VA and VB both upwards, HA to right side. Okay. Now, take moment about A. I already told, see, this is not method of joint. This is finding reaction. This is a coplanar force system. That also I will tell tomorrow. Take moment about A. See, clockwise positive. I wrote here. Minus VB into 12. First of all, explaining this is waste of time. See, moment about A. Minus VB into 12. VA and HA into 0. Plus 30 into 3. Plus 45 into 6. Plus 50 into 9. Plus 24 into 3. Plus 15 into 6, plus 40 into 9, minus 36 into 4 equal to 0. First of all, this if I explain further, then what you had done earlier, how many questions you solved earlier. So you get the value of VB plus 99. Sigma V0, take upward positive. Plus VA plus VB, minus 30, minus 45, minus 50, minus 24, minus 15, minus 40 equal to 0. Substitute for VB whatever you got there. VA will come plus 105. Sigma H equal to 0. Right side positive plus HA minus 36 equal to 0. HA will come plus 36. Okay, now make a note. In the procedure I will tell you. After getting the reactions for method of joint, observe the question. Don't see here. Do not write anything here. This is a question. You should not write anything here. One more sketch. Here only AB I have shown. If there are inclined members are there, find the angle of inclination for every inclined member. See here now. See right here. To get angle of inclination for all inclined members. See. This member is inclined. Let it be theta. See. Now, if I take theta here, tan theta equal to how much? 4 divided by 3. 4 divided by 3. Therefore, your theta equal to 53 point. It is standard angle. Tan theta 4 by 3 means, see, this also I taken care. 4 divided by 3 equal to shift tan inverse answer. 53.1301 degrees. 13 sufficient. 53.13 degrees theta. Now, see here. There is one more member here. See here also it is 4 by 3. If this is theta, this also theta. See, this also theta, this also theta. In this question, for all the 4 inclined members, angle is theta. So, 53.13, 53.13, everywhere, same angle. So, find the angle. Next time I will do a question where this is 3 meter, this is some 4 meter, this is 2 meter. Then theta will change. That will take later. Okay, now, next step. Once you get the support reactions and also angle of inclination for all inclined members, very, very important, you have to prepare a neat sketch. See, you have to prepare a very, very neat sketch. It is very, very important. A very neat sketch, which is that neat sketch is the master sketch. Little bigger required. See here. Little bigger. Okay. Somewhere here, up here. Space is there? Yes, space is there. Okay. No problem. See. This way. 4, 3, 3. Up to here I can go. 1 minute. From here. Okay. Little more here. Okay. Okay, sufficient. Master sketch. 3, 3, 3, very, very important sketch, 4. Put the frame once again. This is actually, remember, this is called your master sketch. See, this is the master sketch. Why, I will tell you later. Okay, now, see, the members are, put all the members here, correct? This way is correct. That is important. This way and here, this way. Put the sketch. Then, everywhere, see, in the question not given, but I told you, every joint is a pin joint. I always do it, because why? To show that they are pin joints. Okay, then, enter the forces. What is the force here? This force is 30 kilonewton. Kilonewton, 45 kilonewton. I should check the camera once. Okay, I'll check it later. 50 kilonewton. Space problem is there. You should see the solution in the laptop. Don't see in the mobile. 24 kilonewton. This load is 15 kilonewton. This is 40 kilonewton. I tell you, this is a master sketch, 40 kilonewton. Then also enter, then mark the points here. A, this is B, then I told which one? C, D, E, F, G, H. Okay, then there is a hinged support here. There is a roller support here. Okay, see, hinged support, earlier red color unknown, now it is known. There is a vertical reaction VA. See, we assumed upwards, but we got positive. Positive sign indicates that direction considered is correct. So there is a vertical upward reaction VA equal to how much? 105 kilonewton. Now it is known. It is not red color now. It is a black color. And HA, you took right side. That also came positive, correct. A horizontal right side force, HA equal to 36 kilonewton. Then at B, you took vertically upward reaction. It came positive, correct. VB equal to how much? 99 kilonewton. And also mark angle for all inclined members. Write it. No theta. Okay. Write the angle. 53.13 degrees. This also 53.13 degrees. This also 53.13 degrees. Today's class, because I do not want fraction today, 13 degrees. Now, this sketch is the master sketch. We now make a note here. I will tell some note now, important. Now, this all I can remove. See, this all I can remove now. Nothing required. Your master sketch is there. Reaction I will remove. Nothing required. Nothing required. See, when you study something from me, you should always have patience. People who have no patience to listen to what all I tell, what all I explain, they need not continue my class. Better quit. You study somewhere else from a better person than me. Some person who is much better than me. Okay, this is all entry now. See, now, very important concept. Something I will tell. This is our important diagram. Now we will start method of joint somewhere here. As we get the answer, we will keep on entering here. Therefore, right now, see, all member forces are vacant. No entry is made. No entry is made. Slowly, we will start entering one by one in this sketch. So now start. Now I will do one thing now. See, in front of you only, this is for you to give confidence, or for you, see, now this sketch is not required. I will remove this sketch. Okay. See, that sketch I remove. Imagine removed. Okay, removed. Now, if make a note. If this question is given to me and somebody will ask me, you find forces in all members for the given frame. Sir, give the question, sir. Okay. In a paper, he will give questions. Then he will tell, okay, now, how many papers you want? I will tell, no, nothing required. No paper. No paper required for me. Give me a calculator and pen. I will write the answer here. But remember, actually very high speed I can write the answer. That I will show you when I give exercises for you. But when I fill up the answer, somebody will ask, how you got? So today, I will get the answer by telling something. If you follow it, no problem. If you don't follow it also, no problem. But that is, I am risking my teaching now. See, by entering an answer now and later solving there, if answer is not tallying, I will be in trouble. So, I will get ready now. Just a minute. Someone will tell, he is stopping because want a small break. A small break I want, little rest. I will come back. Not for studying purpose. See, that question you have to solve now, it reached the stage, continuation little later. Now what I will do? I will get the answer here. If I am solving this question, if somebody gives the question to me, I will tell him, he will give, take some paper, nothing required, give a pen and calculator sufficient. Then I can directly put the answer very fast. That I will do it later when I give exercises. But here, I will tell something as I calculate, see what I meant, I think that I will keep on telling, see, oh that is 0.5, etc., that way. See, you need not bother. There may be people who may be knowing, having good control on this, they may having good knowledge. They may understand. But anyway, later stages, I may explain this one more details. Today not required. Purpose is only one thing. Just to show you, listen to, go through each and every class. I upload mechanics, SOM and SA, later RCC steel will be there. See what level you can reach. Okay, now I'll start. I'll use red color. See, this sketch is not required now. I'll write the answer now. See, I want first reaction. 30 plus 24 is 54. 54 into 0.75 plus that is 90 plus 90 into 0.25 plus this half is 30 plus that extra reaction of 36 into 4 divided by 12. This reaction, I got 105. I am not saying there. I got this reaction 105. And 36 means this is 36. I am not writing VABB. Then this reaction, total 30 plus 20, 54. 54 plus 60 plus 90 minus 105 will give 99. I am not saying there. See, 99 kilometer. I start from joint A or start from joint here. This joint is better for me. Where unknown is lesser. 99, so that component, this component should be 99, so that 99 I will divide by sin theta. Theta is in memory. I get force in this member. 123.75. I get force in this member immediately. 74.25. 25 kilonewton. Then I will come here. 105 up. 105 sin component is by sin theta. 131.25. See, I can do any order. All kilonewton into 0.6 is there. I subtract 36 because of outgoing force. It is this way of 42.75. This is 15 means this is 15. Directly I will put. Y means no answer. I can't explain why. Now I come to this joint. This is 36, so 131.25 into cos theta is 78 point something is coming out. It is coming this way. Then therefore, no, it is 78.75. Then this vertical force 131.25 into 0.8 is 105. Subtract 30, 105 subtract 30, I will get 75 down. I will get 75 down. Then I will come to this joint. 75 up, 24 down. 75 minus 24 is 51. Its sine component theta, 0.8, 63.75. Up means down. .75 into 0.6 is that component, plus 42.75 is 81 this way. Come to this joint, or any joint will do, with this joint will do. 131.25, 123, 123.75 into 0.8 will give you 99 up, 50 down is there, I subtract 50, 49 down. 49 kilonewton. Then this horizontal force there. 123.75 into cos theta, 74.25 plus another 36 is there. That will give you 110.25. This way, okay. Last member here, 40 down, 49 up. 9 divided by 0.8 is 11.25. Up means down. See, I took this much time because I was murmuring, I was telling what I was doing. Otherwise, not required. I will do one thing, for safer side, I will check this joint. Actually, not required. Okay, I will check the joint. Okay, leave it now. Answer is over. Now, don't say this one, fine answer. If it is an offline class, what I will do is, I will tell the students, if you want to do one thing, you cover this one. Sir, not required, sir. We know, sir. Okay. I am not, now see, when I saw this question, I am not seeing here. I will complete this question. When everything is over, I will stand here and look there and compare with my answer. Okay. I will start now systematically. See, now it is important for you. See, note, now it is for you. Now onwards, important for you. You never bother what I did here. Okay. Systematically, we will solve now. Okay, we'll start. Everything answer is, oh, sorry, one member missing here. What is there? Oh, I forgot. Okay. I looked there. One, if I know that much, can't I put this answer? Okay, now leave it. Don't see anything here. Now, see, now our class starts. See, when I'm standing here, I'm not bothered here. But see now. Now start. Now, solution by, see now, analysis continued. Analysis by method of joints. Method of joints. Procedure I will tell simultaneously. I told next class I will tell. Now, those who want to understand should do one thing. See, you should take some photograph. I will tell you why. I will tell, take a photo. First take this photo. Write photo number 1. See right here. Photo number 1. Photo number 1, screenshot. Okay, take photo number 1. Now, tomorrow I will give procedure for you. After finding reactions, I told you, enter the reaction without any sign. If you get negative, what to do, all I will tell later. And then, inclined member, mark the angle. Then, start the solution, method of joints. Start from a joint having not more than two unknown member forces. See here, I will tell you. If I see here at C, 3 members are there, not possible. D, 1, 2, 3, 4, 5. 5 members are there, not possible. E, 1, 2, 3, not possible. B, yes. So, B possible right here. Or F, no, 1, 2, 3, 4. G, no, 1, 2, 3. H, 1, 2, 3, 4. A, 1, 2, or A. Any one will do. Actually, B is easier. No, I will start from left hand. Okay, now I will do one thing now. See. Consider equilibrium of joint A. See, joint A. I will tell what you have to do. I will tell first draw a pin connection here. See, pin. Mark a pin. This pin is your A joint. See, this pin. Okay. Draw one vertical line, light line, and horizontal line. This all I will tell you tomorrow. Okay. See, this is your A. Then, first enter all the reactions acting there. Yes, there is a reaction. Now VA not required. You write here. This is, see, direct answer. Now reaction not required. Name. It is known for you. 105 kilonewton and right side force of 36 kilonewton. 36 kilonewton. See how much you can make out. By the time I finish, it will take more than 1 hour. Then someone will tell, sir, you took only 2-3 minutes. 2-3 minutes because I was explaining and doing. Explaining for those who can understand. If that explanation is not required, I need only 1 minute. That's all. Okay, now start. Then also mark any external force there. No external force here. Then consider the member forces there. See, one member this way. See here. One member this way. One more member this way. Red color I put. 2 unknown member forces. Now, inclined member means mark the angle. Always mark the angle with horizontal. 53.13 degrees. Then, name the forces acting at the joint. This is AC member. My joint is your finger should be at the joint. Don't remove the finger. Okay. Force coming here is force for the joint A from AC. So this is your P AC, not CA, PAC. If you write here, it is PCA. Here it is P force at A for AC member acting to this joint. This is, see, P, your finger is here, PAH, unknown forces. Okay. Now, direction required. This I told you last class. See, I have given an example for you. See, right here. I uploaded a class, pre-requirement for method of joint without lecture number. You should go through that first. Those who have not gone through that one, they are not my students. They are not following everything I am telling. So sorry, that is your problem. I told when you have to assume the direction. Some people will tell, assume compression tension. No. Compression tension is no. Then what about this one? What about this one? External forces, direction. If this is direction, this is also direction. One day I will upload a class in YouTube proving your theory is wrong. Okay. Now, this today's class, what I will do is, first one, just make a note here. Actually, it is possible to assume the direction correctly by observation. But imagine you do not know. Actually, I know it direction. I know 100%. See, I know that 100% this force is like this and this force is like this. I 100% am knowing. That is, so if you know correct direction, then if you can How to decide, I will tell later. See, I told next class more than 1.5 or 2 hour procedure. There I will give hint for you. So sometimes some people take all tension. That is a wrong concept. It is only for amateurs. Sorry, people who don't know anything. Don't take that way. So direction you assume whatever you want. But so you make a note here. This question, what I will do is, I do not know. Therefore, imagine I am not knowing anything. Okay, then some direction required. Okay, we will take like this, both outgoing. Okay, both outgoing. Why means, suppose somebody will ask, why this way? I don't know all these things, difficult for me. So who will struggle? That force is this way, component, something. Mr. KSN was telling earlier, I am only KSN. He told earlier, but for him, okay, but what about us? No. I will take Rasi, randomly assumed. Okay, start now. And now immediately, green color. This I should not tell. Green color. Cos, sine. Okay, now make, start. Sigma, one of them is horizontal, other is inclined. Eliminate the horizontal. Inclined, you see, inclined you cannot eliminate. Inclined will come. You eliminate the horizontal by taking sigma V0 first. Actually, anything will do. Suppose you take sigma H, nothing will happen. Okay. I will take upward positive. What do you get? See. Plus PAC sine 53.13 plus 105. This only will tell it is wrong, equal to 0. See, these two no component. PAC sine 53.13 plus 105. Therefore, you will get the value of, I will put some space required, okay, right here. Therefore, you get the value of PAC. Answer will come in kilonewton. Calculate. I am not seeing there. 105 divided by sine 53.83. Calculator is not on. 105 divided by sine 131.25 plus, not plus, minus 131.25 kilonewton. Then sigma H equal to 0. Take right side positive. Then see, PAC already over, unknown first, plus PAH plus PAC cos plus PAC into cos of 53.13 plus 36 equal to 0. This I should not explain. Why? It will be insulting for you. Now what you do? Substitute, I should check the camera, substitute PAC. See, now we'll go to equal to how much? Minus 131.25. We get PAH plus bracket minus 131.25 into cos 53.13 plus 36 equal to 0. Therefore, you get the value of PAH. Correctly observe procedure, kilonewton. I should check the board once. Is it going out of the board, camera? I think no. No, it's okay. Substitute there. See, not once I lifted my head and looked there. It is minus 131.25. Calculator is not on. This calculator, if I keep for 2 minutes, it will get switched off. Minus 131.25 into cos theta plus 36 minus, this is plus 42.75. Your PAH will see, this is minus, take that side. See, this I cannot tell because high school mathematics. So how much I told? Plus 42.75. 42.75 kilonewton. Okay, over. Now is the one photo already over. Now is the most important. Make a note here. Make a note. I will dictate. But it is very powerful note, red color. Joint A completely over. We got answer for both unknowns. Which joint? A joint. Go to that main sketch. Put the finger at A. Which joint you solved, use the same joint here. Don't go to other joint. See here, put finger here. See how you consider the force. Simply consider whether it is outgoing or incoming. That is better. Going away or coming. See, either you tell going away or coming towards the joint. See, PAC we considered going away from the joint. These all those who want right here. We considering what PAC considered going away from the joint. Here, this finger here. But answer we got negative. Negative sign indicates that it is not going away, it is reverse. It is coming to the joint. Okay, enter here. See? How much answer? Now no negative now. See? 131.25 kilonewton. No negative sign now. Okay, then this member PAH we took what? Again going away from the joint. But we got positive. Oh yes, correct. So it is really going away from the joint. How much answer? 42.75 kilonewton. Enter. Immediately, very, very important, go to other end. Other end. See, if it is coming to the joint, it will be same, or what direction you got here, enter the opposite. Means if you got to see whatever you got here, enter opposite here. Whatever you got this way, enter opposite here. Okay. This is, remember, this you are right. After entering the answer at A, for this number, go to other end, put arrow mark. See how it is here. See, if it is this way here, put opposite there. If it is this way here, put opposite there. Now do one thing. Take one more photo. Take photo 2. Very important. Photo 2. This photo you take. Now for next step, you refer photo 2. Very important. Okay. Photo 2. See, I know the force is coming this way. Deliberately I took wrong. So it is our choice. Okay, now select the joint having not more than 2 unknowns. See, earlier I told C you cannot go because 1, 2, 3. But now this answer is known. Now unknowns are only 2. Therefore right here, now you can go to joint C. So now write next, consider equilibrium of joint C. Okay, this C. Immediately put a sketch here, see. Put a pin here, C. Draw one vertical line and horizontal line. This is your C. Okay. First, any support reaction is there marked. There is no support there. Oh, but also, there's one force here. Oh, if I have forgotten that one, gone case. Okay, no problem. I would have make out because when I come to equilibrium, I can make out. Okay, I forgot here. Okay, okay. Support reaction is not there. Then any external force, yes, 30 kilonewton. Enter it. It is given there. It is 30 kilonewton. Then first mark if any known member force is there. See, when you do joint A, no. But when you do, yes, someone will tell, yes sir, I can see a force which is known. How is it? For the joint C, see, it is like this. See the arrow mark there? It is like this. That is very important. See, it is like this. This is force in, when you write here, see here it is P for AC. Here it is P for CA. P for CA, which is known for you, how much? 131.25. Remember, it is red color now, later become black color. Why? It is known value. Okay, inclined means mark the angle. 53.13 degrees. Okay, then there are two unknown forces there. Mark it here. One force here, one more force here. Okay, then this is force in CD. This is force in CH. Now, direction required. I will tell something for you. See, this is acting this way. These two are vertical. To balance, this should be like your choice. You can assume whatever you want. If you got confusion, take this way only. Okay. Now, then, this is going up. That is down. This is a heavy force here, up. So this upward force very predominant. This is lesser. So because of these two, it will start going up. To balance, I require down. Because I know it is down. See, this direction is your choice. If you got confusion, I told last, see, preliminary class I told, unless you go to preliminary class, don't come here. If you are not gone, stop here. Go to preliminary class, previous to previous class. Class number 317. Class number 317. Without lecture number. Without mentioning anything, without telling what is stress. That is equilibrium cases. Okay, start now. Sigma V equal to 0. Anything first. Upward positive. See. Here. Minus PCH. See. Minus PCH. Oh, sorry, here. If you want to understand here, see. Right side and upward. Cos sine. Okay, if you want. Okay. Minus PCH. Minus 30 plus 131.25 into sine of 53.13 equal to 0. Therefore, you get the value of PCH in kilonewton. Or calculate 131.25 into 0.8 minus 30. 75. 131.25. Correct, 131.25 into 0.8. So much, that is 105 is minus 30. Will give you 75. Okay. It will come plus 75 kilonewton. See, plus 75 kilonewton. That force. Then, sigma h equal to 0. Take right side positive. Minus PCD. Minus PCD. These are not there. Plus 131.25 into cos 53.13. See, this I can't explain. If you don't know this one all, you are not studying from me engineering mechanics resolution how many times over. Therefore, you get the value of PCD. PCD will come 131.25 into cos theta. 78.75 plus 78.75 kilonewton. Okay, make a note here. We got both the answer positive. Means both we considered are correct. What direction we considered for the unknown is correct. So enter in the same way. But remember, with joint, C joint, put the finger at C. See here. Go there. PCD you took like this. Plus came. Enter. How much? Sorry, this side put last. See, it is a habit. It is a habit actually. Okay. 78.75. 75 kilonewton. PCH, we took what? We see from C, you took like this, going away. Answer came positive, correct. 75 kilonewton. Okay. This also over. Next. Now, next consider equilibrium of joint. See now, A over C over. I think you can come to H. See, earlier at H, 1, 2, 3, 4 unknowns. you cannot solve. But now, if you come to H, two are already known. Therefore, one thing, now do one thing. With this entry, take photo 3. Photo 3. One more photo you take. So that when I start next joint, this photo you have to refer. Remember, photo 3 or screenshot 3. Okay, now consider equilibrium of joint H. Feeling a little tired because non-stop I am talking. Okay, start. Joint edge. Where is joint edge? Here. See. Put a pin. This is your edge. Okay, put 2 lines here. See, this is your edge. Okay, then first, if any supports are there, here, enter the reaction. No support. One external force is there. Enter there. 24 kilonewton. That's all. 24 kilonewton. Then, after that one, if any member force is there, it's already known. Enter. Yes. We know one member force. See, this, not this one here. See, one member force here, this way. One more member force this way. See. Remember, at this joint, left side and upward. See, here it is AH, here it is HA. This is PHA. PHA, already known for you, 42.75 kilonewton. And other one is PHC. PHC equal to 75 kilonewton. Okay, then there is one unknown force here, one unknown force here. See, unknown forces like a PHC. I'll put here now. Space problem. 1 minute. What is one? PHC equal to 75 kilonewton. One unknown here. See, this unknown is PHG. PHG. This unknown is PhD. PhD. If you do study well, you better do PhD. Okay, then angle for inclined force 53.13 degrees. Now, direction. This time, again I will do one thing now. I will randomly write, okay, just for fun. See, I will take both are like this. Y means no answer. You write here. He takes randomly. See, randomly. See, correct. I can take, I know the direction. When I am not supposed to see that. When I can solve the question directly in calculator, do you think I don't know how to take the direction? Yes, but majority people cannot understand properly. So, you can take whatever you want. Okay, now, there is one inclined force here. Be careful. For this force, I should not tell. See, this way and this way, cos, sine. If this is not clear, don't continue my class. Okay, start. Joint edge. Sigma, one inclined, one horizontal. Eliminate horizontal by sigma V0 upward positive. See, minus PHD minus P for HD into sine 53.13 minus 24 plus 75 equal to 0. See, this is not there, this is not there. So therefore, you will get the value of PHD. PHD will come, see, minus 24 plus 75, it will go that side, 51, it will go that side into minus 1 divided by sine theta plus 63.75 PHD plus 63.75 kilonewton. Then here sigma H equal to 0 plus actually right side positive. Okay, start. See, but unknown, PHG already known for you, minus PHG minus PHD cos minus, not SPHD, minus PHD cos 53.13 minus PhD cos 53.13. See this over. Then these are not there. Minus 42.75 equal to 0. See now. Substitute which one? PhD equal to how much you got? Plus 63.75 kilonewton. I am writing everything today. Therefore, minus PhD minus PhD is plus 63.75 cos 53.13. See, next time I will not write this way. Minus 42.75 equal to 0. Therefore, you will get the value of PhD. Calculate. Minus becomes plus there. Minus 63.75 into cos 53.13 minus 42.75 is something wrong. Minus 63.75 into cos theta minus 42.75 is plus minus 81. You are getting minus 81 kilonewton. You got minus here, minus here. See, this become plus minus here, this minus here, this will become plus. Okay, minus 81. Okay, now immediately make a note. Put your finger, come here, where H joint. See now. Force in this member PhD we took at the joint H, finger should be here, coming to the joint PhD. Answer came plus. Oh, correct. Enter here. See, I forgot to tell last time, enter this value. I forgot to tell that one. Okay. Now you know it. How much it is? 63.75. Okay, I'll enter here. 63.75 kilonewton. PhG we took coming to the joint. But answer came negative, minus 81. So, this PhG is not coming to the joint. It is going away from the joint. Negative came. Now no negative. See. Now no negative. Be careful. Now we put negative, nonsense it becomes. Okay, over. This is also over. Now, next joint. Now consider equilibrium of joint. Now I can go to G. See here. G. One of the easiest joint to operate. And I want a little rest actually. Feeling little tired because of non-stop talking. See, I am also a human being, aged also. Okay. G. See now. When I come, 1 minute. Now take, after entering this one, take photo 4. Now to continue, refer this photo 4. That's simple. Otherwise what happens is, later when you study, you will not be knowing step by step installment. Okay, start. H, see here. First put a pin, I tell G. G. Put a pin here. This is very simple pin. This is your G. See. This is your G. Draw one vertical line and horizontal line. Then one force going this way. See here. First of all, one vertically downward force of how much? 15 kilonewton. One force going, this force going left side. It is P, which one? PGH equal to 81 kilonewton. Then that's all. One unknown here, one unknown here. Okay, now if you think a little, you can make out. For equilibrium, see, there's a rule later. If four forces are coming here, then each line forces are equal and opposite. Somebody common sense will tell. So I will assume like this. Assume like this. This is force for GD at the joint G. Force for GF. GF at the joint G. No inclined force. Okay, over. Sigma V equal to 0, upward positive. What you get? Plus PGD, see, minus 15 equal to 0. Therefore, your PGD equal to plus 15. plus P, correct. Okay, then sigma H equal to 0. Take right side positive. Okay, black color, I forgot black color. Okay, plus PGF. Now I require rest because I'm feeling a little tired. Plus PGF minus 81 equal to 0. Therefore, your PGH equal to plus 81 kilonewton. Okay, right here. Both values you got positive, means both assumed directions correct. So, G joint for this member going away, PGD 15 plus you got. So, see here, plus 15. This force we took like this at this joint, plus 81 came, so this way, 81 kilonewton. Now do one thing, immediately see, if it is this way, opposite here, if it is this way, opposite here. Now do one thing, take photo 5. Actually not photo 5, you write it. Okay, now we are coming near the end of this one. Okay, next. Now do one thing, consider equilibrium. Now make a note, we can go to joint D. No. 1, 2, 3, 4, 5, 6. 6. Okay, unknowns are only 2. But total 6 forces are there. Think of an alternative arrangement. Yes, you can do one thing. Instead of going to D and struggling this much forces, you better go to joint. You see, F you cannot go. Why? 1, 2, 3 unknown. Here you can't go. But B you can go. Okay, change it. Joint B. Change the party. So far from left side, stop from left side, start from right side. See, this liberty is not there if it is cantilever type. I will tell you later. Okay, this all I will tell you later. Okay, consider equilibrium of joint B. Okay, start. Put a pin. Joint B. One vertical line, one horizontal line. This is your B. There is a support reaction here upwards of 99 kilonewton. Then there is one horizontal member here, see, this way. That is PBF. PBF. This one. This force. One force goes this way. Here. That is PBE. BE. For that force, angle is 53.13 degrees. Now, assume the direction. I will tell you something, see here. When this is upward, to balance it, I know it, this will be downward. Okay, then when this is this way, its horizontal component is to right side, so to balance it is left side. So I will assume like this. Actually, you can make a note. He used his brain and used his knowledge and assumed. If you got confusion, I told you, you can take whatever you want. Joint B. 1 minute, space problem there. Joint B. Okay. Now, this is inclined force here. See, therefore, safer side, confusion. See, cos sine. Start. One horizontal, one inclined. Eliminate the horizontal by taking first sigma V equal to 0. Upward positive. See here, upward positive. Minus PBE sine 53.13, unknown actually, minus PBE into sine 53.13 plus 99 equal to 0. This will not come. Therefore, you get the value of PBE. Oh, 123.75 plus 123.75 kilonewton. Then see, when you write the answer, sign is very, very important. Then sigma H equal to 0, right side positive. Here, unknown is first unknown. See, minus PBF, minus PBF, minus PBF, plus PBE, PBE, cos 53.13. That's all, equal to 0. This has no component. Do one thing. Substitute PBE, whatever you got, plus 123.75. I am feeling tired, therefore you write substitute, therefore you get the value of PBF. At least that much you can do. Substitute, see, PBE equal to how much? 123.75. 123.75 into 0.6. 74.25 plus 74.25. Okay, now do one thing. Make a note. Oh, both the answer came correct plus. That came plus because it is assumed by me. I know the direction. Suppose by chance you take this way, negative will come. Then you reverse it. Okay, now go to joint B. See, joint B. Put the finger here. This force we took like this. See, coming to the joint BE. How much? 123.75. Correct. Assumed direction is correct. 123.25 kilonewton. And this force from the joint B we took going away this way. Again came plus. Correct. How much? 74.25 kilonewton. Now, if it is this way, enter opposite here, enter opposite here. Okay, then now take photo 6. Photo 6. Really feeling tired. We will take some 10 minutes rest and start. Okay, now next, there is a small discrepancies there. Okay, next I already written because feeling tired, I wrote now. See, you take photo 6, but one thing important, see, when I solved here, I am not getting 49, this force. But what happened is, I saw that I did not see that answer. I will tell honestly, why should I look at there? When I got the answer here, I am getting slight unbalance here. Then suddenly I saw, oh yes, see, make a note, go back earlier, see, go back earlier to joint, which one? Joint B. At that time, your force in BE, see, that force in BE, how much I got? 123.25, no, it is 123.75. Because I will tell you what happened. Answer came 123.75 only. Otherwise, you won't get 74.25. See, 123.25 into 0.6. Otherwise, you won't get, what is it? 123.75. 123.75 into 0.6. Otherwise, you won't get 74.25. What happened is, it came 123.75. In the light, see, dim light, calculator, you can see, it is not visible. So what happened is, it looked like 25 for me. So I wrote 25. No, make correction there. You see there, you go to previous joint, it is 123.75. Make a note. Now, not a mistake, print mistake. This, see, anybody, this will happen. See, honestly, I will tell you, I have not seen that diagram because I got confidence in me. Because if it is 123.25, I am getting a slight unbalance here. Slight unbalance comes here. What unbalance? You don't bother. I can make out. Suddenly I can make out there is an unbalance here. Then I saw what happened. So, previous one, see, this B is 123.75. So, you do one thing. All you have to do is, you go back to previous solution of B, where I wrote PBE equal to 1. If I wrote, maybe it is possible, I might have written 123.75, but make a wrong entry here. That also possible. See, maybe I got 123.75 on the board, but while entering here, maybe by mistake, I entered 25. So change that 123.25 to 75. Okay, now start. Now consider which joint. Tell me. Now see E, F and D. Any joint will do because only two unknowns. But D we will avoid. It's a traffic jam. See, D is like a traffic jam. No, do it. So I will do one thing. My choice. I will go to E. Consider equilibrium of joint E. See there, 50 down. See, 36 left side. 123.75 this way at angle of what? 53.13. Then one unknown here. P for ED, P for EF. This time I will do one thing. P for ED and P for EF. Both I will take, see, both this I will take left side this way. This I will take this way. Actually, I know that this is wrong. This is actually like this. This I know is like this. Deliberately I am taking wrong. Why? Just to show you that it is your choice. You can take whatever you want. So I felt like, see, you write here. Somebody may comment, hey, this person does not know. I know. You see the board. I solved the entire question without writing anything. Just if I tell those things now, some will get confused, sir, not clear, sir. See this component. No, you take randomly whatever you want. Okay, I have taken like this. Sigma V0 upward positive. See, plus PEF plus 123.75 sine 53.13 minus 50 equal to 0. PEF will come minus 49. Then sigma H equal to 0. Right side positive. Minus PED minus 36 minus 123.75 cos 53.13 equal to 0. PED will come minus. Now come to the joint E. Make a note here. We considered forces, both unknown forces. See, PED, we from the joint E, we considered going left side. But answer came negative. Therefore, it is to right side. See, what you assumed here, opposite. How much answer? 110.25. 25 kilonewton. And then PEF, we took coming to the joint. Again, negative came. So it is wrong. Opposite. Now, see, now no negative. How much? 49 kilonewton. Now immediately see if it is that way, put opposite here, put opposite here. Okay. Now make a note. Only one member is left out. See, lastly, everything is over. Make that correction there. Actually, maybe I wrote first 123.75 only, but while in the light, I might have taken by wrong. Okay. Now lastly. See, now only FD, if I call here, it is FD. 1 minute, photo 7. Take photo 7. Now refer this photo now. Take photo 7. Now, only one member FD. F is better than D. So, consider equilibrium of joint F. See. Consider equilibrium of, see this question, I am writing everything, joint F, how, put a pin here, see. This way, okay, this is your F. One force acting down of 40 kilonewton. 40 kilonewton, see here. Then, one force acting that side, it is a member force, that is P for, which one? FP. I can put it black color only. Next time onwards, known forces, I will use black color. But here, red color. Okay. Equal to how much? 74.25. Writing is black. one more force going this way. That is P for Fg equal to 81 kilonewton. Then one force going upward, see here, that is P for Fe. Fe equal to 49 kilonewton. Just one unknown force is there. Since you are considering joint F, it is called PFD. Direction, take randomly whatever you want. Okay, take randomly whatever you want. Okay. This angle is 53.13 degrees. Now, if you resolve, see here, cos sine. Now, take a note, only one unknown is there, which is inclined. If you want, you can do only sigma h0 or sigma v0. Okay, suppose you do, see, right here. Suppose, see, anyone you can do. Suppose sigma v0, upward positive, sigma v0. Sigma v0, upward positive, then plus PED sine, plus PED sine 53.13 plus 49 minus 40 equal to 0. Your PED will come 49 minus 40 is 9. 9 divided by 0.8. It will come negative. Minus 11.25. 11.25 kilonewton. Over. Right here. Or, make a note, or those who want can consider sigma h equal to 0 also. Then see what will happen. If it is sigma h0, then see, minus PED cos minus PED cos 53.13 minus 81 plus 74.25 equal to 0. They also will get PED equal to same minus 11.25 kilonewton, guaranteed. Whichever you take, answer will come same. Okay, check it. Minus 81 plus 74.25 divided by 0.6. Yes, minus 11.25. Okay. Now, enter the answer. See, force in this member we took this way. See, this way. Negative came, so reverse. How much it is? 11.25 kilonewton. If it is that way, opposite here. Now take photo 8. Photo 8. That is last photo. Last photo. Right here. Trust one statement you are right now. The given pin jointed frame is completely analyzed. Nothing left. Now, time has come to check whether what he wrote earlier within no time. Actually, he took around, you write here, he took around 2-3 minutes because he was explaining for those who can understand. Otherwise, I may take only 1 minute. Okay, right, start. 131.25, 78.75, 110.25, see, 123.75, 74.25, 81, 42.75, 75, 63.75, 15, 11.25, 49. Yes! What celebration! One of my friend is very good instructor. Suppose I do this way, if you see, he will call me and tell, hey, what is this? You celebrate for such a silly one. If you don't get this one, you are not fit for teaching, he will tell. I will tell him, no, for others' sake. I am not celebrating. I know answer will come. By chance, if there is any calculation mistake here, I would have corrected it then. It will, see, sometime later, when I give answer, it is possible. Some rare times calculation problem. Okay, now one last note you are right. Note. It is not required. Note. One joint we have not gone. That is a traffic jam. Which one? Joint D. See here, make a note here. One joint we have not gone. That is D. But that also, right here, that also should be in equilibrium. Let us check it. There is no unknown there. How to check it? We won't equate sigma h to 0. We will find sigma h and find sigma v. Both should come 0. Therefore, one joint. See, I forgot one thing here. See, if it is arrow mark here, I forgot here. Okay. Now, do one thing. Cut. Joint D. See here. See the sketch here. Sigma, sketch is not required. Okay, you write sketch. Sigma V equal to, take upward positive. See here. Minus 45. This is a check actually. Check. Minus 45. Minus 15. These are not there. See. Plus 63.75. Sin 53.13. Plus 11.25 into sin 53.13 equal to calculate. Or if you want to do one thing, draw the sketch. If those who want, see, if you are feeling confusion, what you do? You draw a sketch there. See. Draw a sketch. Okay, calculate. Minus 45, minus 15, plus 63.75 into sin theta, plus 11.25 into sin theta. Beautiful 0. And sigma h equal to right side positive, plus 78.75, minus 110.25. This is not there. See, plus 63.75 cos 53.13 minus 11.25 cos 53.13 equal to, I am guaranteed 0. Okay, check it. 78.75 minus 110.25 plus 63.75 into cos theta minus 11.25 into cos theta. 0 is something wrong. 78.75 plus 110.25. Both are negative. Sorry. 78.75 minus 110.25 plus 63.75 into cos theta minus 11.25 into cos theta. 0. Yep. Perfectly all right. Now, nobody can find one single mistake in this class. Now, everything over. Now, one last thing is there. I will do that also, see. Sometime, see, after everything is over, you present the answer. Lastly, see. This final result. Final result. See, I will do somewhere here. Okay. See. Member axial force in kilonewton, then write nature. Start in order. Member AC, then CD, DE in some order, DE, EB, BF in order, BF or FB, anything, BF, FG, GH, HA. Space is not there, then see, space is not there. I will continue, where to continue? HA over, then see this over, CH, HD, space is not there. I will write here HD over CH over HD over DG. DG, you continue here. DG and DF. You continue here and EF. Don't waste time. Axial force, start. No sign now. 130 kilonewton, 131.25, 78.75, 110.25. That way, enter for all the members. Now, lastly, nature. See here. This one. Coming to the joint. Compression. Again, coming to the joint. Compression. Now, EB, compression. BEFC, this way. Tensile. That way complete. See now, I will tell you. See, I told you, any member force, if it comes towards the joint, it is compression. I told earlier, see, towards the joint is compression, whereas going away from joint is tension. Okay, now therefore make a note here. Compression, tension, compression, tension. You write that way. It is not important now, but write it to complete the question. This next question I will write. There is no time to write also here. This anybody can do it. Tension, compression, you have to decide. Okay, now I systematically explain. Next class I will give procedure with a lot of concept. So, but now once you understand this question, you can easily understand procedure. That is the advantage. Okay. Use this opportunity of such a detailed solution, learn and get solid grip. And as usual, I will tell, improve the knowledge. Okay. Thank you. Next class we'll meet.